Today's lesson on properties with regards to powers continues where we left off yesterday. Yesterday, most of our rules were driven by the product of powers. Today, we're going to be dealing with the quotient of powers in some way. So what we're going to see here should be pretty intuitive. We learned with the product of powers, we added the exponents when the bases were the same. It would seem logical that with the quotient of powers, where the bases are the same, and the exponents are different, since we're dividing, we're going to subtract. And we can see that's actually the case, because if we take 8 to the 10th divided by 8 to the 4th, rewrite it as a fraction, and accordingly rewrite each part of our fraction as a product, 8 to the 10th is the product of 10 eighths multiplied over 8 to the 4th is the product of another 4 eighths multiplied, and we can begin to knock these out in pairs. Every time I cross an 8 out in the denominator, I cross one with the numerator. There's a second pair, and a third pair, and a fourth pair. So what we wind up with is 6 eighths multiplied. So we should be able to quickly see that 8 to the 10th divided by 8 to the 6th, divided by 8 to the 4th, is nothing more than 8 to the 10 minus 4, which is 8 to the 6th. Likewise, if we see division in disguise because we're multiplying terms that are reciprocals, I can take something that looks like this, x to the 6th times 1 over x to the 4th, and I can think of x to the 6th as written over 1. And if I wanted to, I could essentially think of this as 8 to the 6th times 1, x to the 6th times 1, which is x to the 6th, over 1 times x to the 4th, which is x to the 4th. And that's going to be the same as seeing it with the division sign. So here we should quickly be able to recognize that this is going to be x to the 6 minus 4, which gives us x squared. So a rule we can quickly write is when dividing powers with the same base, and different exponents, that's the key here. We're obviously going to keep the base, and we're going to subtract the exponents. So really just the inverse of what we did yesterday. When we multiplied, we added the exponents. When we divide, we subtract the exponents. Okay. So I want you to quickly go through these. You can pause the video and you should be able to have the final answers when you bring the video back up. So you can see with this one in particular, this is similar to multiplying numerators across over multiplying denominators across. So this becomes 4 to the 8th over 4 to the 5th. Subtract the exponents 4 to the 3rd. This last one, we had a product rule on top before we moved on to the quotient rule. Moving on, this is very similar in terms of the power of quotient property. We saw this as the power of products property yesterday. We essentially can distribute this exponent into each term. So for simplifying, all we're going to do is to follow the rules. So we're going to take that 4 as the exponent and apply it to the numerator of 2, which gives us 2 to the 4th, and apply it to the denominator of 3 and write it as 3 to the 4th. Remember, this would not be the answer if we were evaluating. I'm sorry, if we were simplifying. This would be if asked to evaluate. We know 2 to the 4th is 16 and 3 to the 4th is 81. And then we can simply just take a look to see if we can reduce that further. Okay, same thing here. This, when you see the example down below, would be as if we were being asked to evaluate. So make sure you understand the difference between simplifying, which is just following the rule, and evaluating. Okay, so here we can say, as a rule, when a base is made up of the quotient of terms all raised to a power. And here's where we're going to use this word loosely, so put it in quotations. We can distribute the exponent to both terms. Consistent with yesterday, scratching out certain directions in the notes, we're going to do the same here. So I don't want you to evaluate. So go ahead, pause the video, and come back to check your answers. So checking back in, this first problem should be pretty self-explanatory. Just distribute the 2, 5 squared over 12 squared. The second problem, when you have the negative sign, as you do, that represents the fraction being negative. If I have a choice, I like to apply the negative to the numerical part of my expression, not to the variable. But you could just as easily have said that this was 5 to the third, but now you're going to have to say over negative y to the third. So either of those is correct, but when I have my choice, I like to mark my negative sign to the numerical part. This next problem is pretty straightforward. We have a little powers to powers going on, but then make sure you distribute that exponent to all the terms of the fraction otherwise. And then this last problem, a couple things to be aware of. Make sure you line up, and it looks like it's going to naturally take place. You line up your numerical bases from least to greatest. And there's a part where we're using the quotient rule here in the end with the term of b to the 10th in the top and b to the third in the bottom where we subtract. That's where that b to the 7th comes from. So those are your notes on quotient rules. Please complete the Google form and be prepared for us to come back and continue with our discussion of properties of powers when we come back to class.